Let's find the prime factorization of 140. Two 70s are 235, 57, 7 ones are. So 140 can be expressed as 2 square into 5 into 7. That's it. Second bit, 156. 2 sevens are 14. 1 will remain. 2 eights are 16. 2 threes are 6. 9s are 3 13s are 13 ones are. Prime factorization of 156 is 2 square into 3 into 13. Second bit done. Please write down. Start factorizing with 5. 5 sevens are 35. 5 six are 30. 5 fives are again 5. 5 ones are 5. 5 fives are 25. 5 threes are. Whenever you have 5 in the units place, it's better to start with 5. Next, 3. How many times 3 will go in this? 51 times. 3 ones are 7s are 17 ones are. So 3825 can be written as 3 square into 5 square into 17. Please note down. Fourth bit is 5001, 5005. When you have 5 in the units place, better start the factorization with 5. 5 ones are 2 zeros as it is, 5 ones are. Now let's try with 11. 11 nines are 99. 11 nines are 99. How much is the remainder here? 1 is the remainder, na? You can take 1. 91. Okay. Now 7 13s are 13 ones are. Understood? So what is the fact? What are the prime factors you got? Write in the ascending order. Smaller to big order you write. So this is the prime factorization of 5005. Now let's factorize this one. Let's start factorization with 17. Let's start factorization with 17. You can try with 2, doesn't go in this. When you add all the digits, you are getting 22. That means 22 is the sum of all digits. 3 will not divide this number. 5 will not divide this number, as you are having 9 in the unit places. 7 11 will also not divide this number. So 13 also is not, all the prime numbers you try, 7, 11, 13. So 17 will be dividing this number. Let's see how many times. Let us actually divide in the rough column with 17. Please tell 17 fours how much? 68. Subtract 62. Now 17 threes are how much? 17
50.
threes are
51.
51. 51. How much is the remainder? 17 sevens are 119. So 17 is going in 437. I already told 2, 3, 5, 7, 11 are not factors of this number. So these prime numbers will not come in the factorization. After 17, better to try with 19. Okay. 19 twos are 38. 57. 19 threes are 57. How many times it is going? 23 times. 23 ones are. That's it. So we got the factors of, prime factors of 7429. Write down the factorization form. 7429 is equal to 17 into 19 into 23. That's it. Please note. Now let's find the LCM and HCF of these two given numbers. First of all, I will be factorizing 26 to 13 13 ones are. In the same way, I would be factorizing 91. 7 13s are 91. 13 ones are. Now 26 factors of 26 are 2 into 13. Factors of 91 are 13 into 7. Let's find LCM and HCF first. LCM. In case of LCM, uncommon factors must be taken. So 2 and 7 will be taken. If the factor is common in both the numbers, then you will be taking bigger one. Here both are 13. There is no bigger one or smaller one. Both are equal. So any one you can take. So this is your LCM. Quickly find the product. 2 sevens are 14. 14 13s are. Find out the answer. Yes, can you be clear?
182.
182, fine. Now, in case of HCF, you will never take uncommon factors. I'm calling them as uncommon. Why? Because 2 is not present in the other number, 7 is not present in the first number. So you will not take uncommon factors. You will be taking only common factors, and that two smaller one. Fortunately, in this case, both are same. 13, 13. So 13 square, we are not having 13 square or 13 cube. Both are 13. So any one you can take. Generally, we take smaller one. Since both are same, I am taking 13. So I got LCM as 182, HCF as 13. Now I need to verify the given formula. What is the given formula? LCM into HCF is equal to product of the numbers. What is the product of numbers? What are the given numbers? In the given numbers, 26 is A, 91 is B. LCM, I got LCM as 182. HCF as 13. Given numbers are 26 into 91. I need to verify. Just multiply these two.
2366.
2366. Can you multiply these two?
2366.
2366. That's it. If you don't want to multiply, you can even do in this way. You need to show LHS is equal to RHS. Here I'm having 182 into 13. Here I will split 26. Can I write 26 as 13 to the 91 to the 91 to the is 182. Now I can show that LHS is equal to RHS. If you don't want to multiply, you can even do in this way. You can show in this way that LHS is equal to RHS. Got it? Now let us find the prime factorization of given numbers. I am going to start with 2. 2 2s are 4. 2 5s are 10. 2 5s are. Now I will factorize with 5. 5 5s are 25. 5 1s are 3. 2s are 7s are. Sorry. 3 1s are 7s are. 17 1s are. 92. 246 are. 20 3s are. 23 1s are. So what are the factors of 510? 2 3 5 17. 92. 2 square and 23. Okay. Now let's find LCM and HCF. In case of LCM, you will be taking all the uncommon factors. These are the uncommon factors. You will be taking all of them. In case of common factors, you will be taking bigger one. 3 5s are 15, 17, 23, 2 2s are 4. Okay. 15 4s are 15. I'm multiplying 15 and 4. So finally I'm getting 60 into 17 into 23. Now in case of HCF, you can't take any one or any of these uncommon factors. These are not taken. You have to select from the common factors only. And that too smaller one, you will be taking only smaller one, that is 2 is HCF. So LCM is 60 into 17 into 23, HCF is 2. Let us verify the formula. What's the formula? LCM into HCF is equal to
A into B.
A into B. What is LCM? 60 into 17 into 23. 60 into 17 into 23, isn't it? And HCF is 2, numbers are 5, 10 and 92. HCF is 2, numbers are 5, 10 and 92. So I can write 62 as 120. 17 and 23 are prime numbers. I will leave them. Now 5, 10. Shall I write 5, 10 as, just go through the prime factorization. We got 17 into 30, isn't it? 2 5s are 10, 10 3s are 30. 17 into 30. 92 prime factorization. Check 92 for 23 into 4. 23 into 4. 92 is 23 into 4. Now this side, anyhow, I am having 17 into 23. I will write 17 into 23. 34 is a 120. Here I am having 120. So I can say here that LHS is equal to RHS, hence proved. If you have time and if you want to multiply and find the product, you can do that at any time. Multiply all the terms on the left hand side, all the numbers on the right hand side, and show that both the products are equal. You can do that if you want, or else just rearrange the factors and show that LHS is equal to RHS. Is that okay? So let us factorize 336. 2 ones are 6 are 8 are 84 are 42 are 21 are 3 sevens are 7 ones are 2 27s are 3 nines are 3 threes are 3 ones are. Prime factors of 336 are 2 power 4, 3 into 7. Prime factors of 54 are 2 into 3 cube. In case of LCM, if the factors are common, you will be taking bigger one. These two are common factors, so take bigger one in case of LCM. You have to take uncommon factor also in LCM. 16 into 27 into 7. Can you tell the product, any one of you?
3024.
3000?
24.
Is that okay? HCF, out of these two common factors, you will be taking smaller one. And here this is the smaller factor. You cannot take the uncommon factor in HCF. HCF is 6. Okay, let's verify the formula. LCM into HCF is equal to product of the given numbers. LCM is 3024. HCF is 6. First number is 336 and the next number is 54. I will show these two are equal without multiplication. Can I write 54 as product of 9 6 54 can be written as 9 6. Can you tell what is 336 into 9? Any one of you quickly find the product. 336 into 9.
3024.
3024.
3024. So now literally LHS is equal to RHS, hence proved. If you have time, you can find the final product and show both are equal. Did anyone got the final product?
Yes, sir.
Tell.
18144.
1
18144.
8144.
18,144.
144. Isn't
Yes.
it?
Yes, sir.
Okay, fine. So first, let us find the prime factorization of 12. 2 6 are 12, 2 3s are 3 1s are 15, 3 5s are 5 1s are 21, 3 7s are 7 1s are. Let us write the factors. 2 square into 3, 3 into 5, 3 into 7. LCM. In LCM, you will be taking uncommon factors. These three are uncommon factors. Why? Because they are not present in all the rows. So uncommon factors will be taken as it is in LCM. Three is the common factor. It is the factor of all the three given numbers. So if you have common factors, then smaller one you have to take. Here all are threes. So any 1 3 you can take. 4 5s are 20. 7 3s are 21. I think this product will be 420. In case of HCF, you cannot take uncommon factors, only common factors, that is 3. Smaller one out of all these 3, smaller one is 3 only. All are 3s, so no smaller, no bigger. 3 will be the HCF. Right on. 17, 23, 29 are the given numbers. If you notice, all the three numbers are prime numbers. So the factors of 17 prime number have two factors, one and itself. So 17 ones are 17, yeah, 1 17s are 17 ones are 23 ones are 29 ones are. All three are prime numbers. Factors of 17, 1 and itself. 23 factors, 1 and itself. Factors of 29, 1 and itself, all are prime numbers. So in case of LCM, if the factors are common, bigger you have to take, all are 1, so you can take 1. All the three uncommon factors should be taken in LCM. Any one of you, please try to find the product.
11,339.
Can you tell me digit wise?
11,339.
Okay, fine. So always remember, highest common factor of prime numbers is 1. Here 1 is the common factor. In HCF, you are not supposed to take uncommon factors. So all these uncommon factors will not be taken in HCF. Out of these ones, smaller one, so all are 1, so you can take any one. So HCF is 1, that's it. So the prime factors of 8, 2 4s are, 2 2s are, 2 1s are, 9 5 prime factors, 3 3s are, 25 prime factors, 5 5s are, 5 1s are. So write down 8 is equal to 2 cube, 9 is equal to 3 square, 25 is equal to 5 square. We are not getting any common factor, so in LCM you have to take all the 3 uncommon factors, that is 2 cube into 3 square into 5 square, which is nothing but 8 into 9 into 25. 25 8s are, I think it is 200. Yes, 209s are 1800 once you check the product. HCF, no common factor. The only common factor in all the 3 cases is 1. You can multiply with 1. Why? Because product will be same even after multiplying with 1. So when you don't have any common factor, 1 would be the highest common factor. So these are LCM and HCF of the given 3 numbers. Now here the given numbers are 306 and 657. HCF is 9. LCM is question mark. The relationship is LCM into HCF is equal to, can any one of you tell the answer?
A into B.
A into B.
A into B, product of numbers. LCM, we don't know LCM. HCF is given as 9. The two numbers are 306 and 657. Transpose 9. On transposing 9, we will get 9. We can cancel 9 and 306. 9 ones are 9. 9 threes are 27. 3 is the remainder. 36. 9 fours are. $34 into 657. Can any one of you tell me the product of these two numbers?
22338.
22338. Write down. So I would like to give some explanation before starting the solution of this problem. Can you tell me a number which ends with 0?
10.
Any other number?
1000.
Little smaller. Below 100.
50.
50. All these numbers are ending with what? 0. What is the common in these type of numbers? ऐसे numbers जो end 0 से end हो रहे हैं, वो numbers में क्या common चीज है वो मैं बताना चाह रहा हूं. अगर आप फैक्टराइज करें ये नंबर्स को, आप एक चीज नोटिस कर सकते हैं. क्या नोटिस कर रहे हैं आप?
2 and 5.
30 एक नंबर ले लीजिए आप. सिक्सटी, 70, 'सो इन नंबर्स में अगर आप केयरफुली नोटिस करें, हर नंबर में 2 and 5 है. फैक्टराइजेशन जब आप कर रहे हैं ना, every number is having 2 as well as 5. Any doubt in this?
No, sir.
All the numbers are having in their factorization 2 and 5. Apart from 2 and 5, you may even get some other prime numbers like 3 and 7, maybe 11 also. Okay, we have tested few. You can test more and more. You can even take bigger numbers. बड़ा numbers लेके भी आप try करो. अगर कोई number 0 से end हुआ, उस फैक्टराइजेशन में 2 और 5 कंपलसरी है. इसका मतलब क्या है? अगर फैक्टराइजेशन में 2 and 5 है, वो नंबर 0 से एंड होता. वो नंबर किससे एंड होता?
0.
So what I mean to say that every number which is ending with 0 will have in its factorization 2 and 5. Along with 2 and 5, it can also have some other prime numbers like 3, 7, 11, so on. It's not necessary that it should have only 1, 2 and 1, 5. It can have more than 1 2s and more than 1 5s as well. But at least 1 2 and 1 5 should present in the factorization if it is going to end with a digit 0. That means in units place, if it is having 0, then in its factorization you will find 2 and 5, at least 1 2 and 1 5 in the factorization. Why it is so? Why? Because 2 5s are 10. When you multiply any number with 10, definitely it will end with 0. So till now we came to know that every number which is ending with 0 will have 2 and 5 as prime factors. Apart from this, numbers ending with 0, any number ending with 0, you can take any example. For our convenience, I am taking smaller numbers. You can even take bigger numbers, not a problem. Any number which is ending with 0 will have to be, it will be divided by 2. It will also be divided with 5. 2 and 5 will be the divisors of that number. When 2 and 5 are factors, so the number will be divided by 2 as well as 5. What I mean to say is 2 30s are 62 will divide the number, 5 12s are 65 will also divide the number. any number which is ending with 0 will be perfectly divided by 2 as well as 5. When you divide with 2, it will give you remainder 0. When you divide it with 5, it will give you remainder definitely 0. Let us take one of the numbers which is ending with 0 and try to divide with 2 and 5. Which number should I take? I have already taken 60. Tell any one of these numbers.
Sir, 50.
70?
Yes, sir.
Okay, then let me check. 5 ones are 5. 5 fours are 20. Exactly divisible by 5. 2 35s are 70. Exactly divisible by 5. So one more understanding, one more common thing is the numbers which are ending with 0 are divisible by 2 as well as 5. And previously we came to know that those numbers which are ending with 0 will have 2 and 5 in their factorization. So now he's asking me, check whether the given number 6 power n will end with 0 or not. उनो पूछ रहा 6 पावर n 0 से एंड होता नहीं होता, आप चेक करके बताइए. ये है सिंपल क्वेश्चन. 6 पावर n नेचुरल नंबर. n क्या है? नेचुरल नंबर. बोले तो n की जगह आप 1 लिख सकते, नेचुरल नंबर 2 लिख सकते, क्यूब 3 लिख सकते. क्या 0 से एंड होता? 6 पावर 1 इज 6, 6 स्क्वायर इज 36, 6 क्यूब इज 216, 6 इंटू 6 इंटू 6 216. मेरे को कहीं भी 0 नहीं आ रहा. उन्होंने चेक करो बोल रहा. n की जगह नेचुरल नंबर ले सकते आप. तो 0 तो आप देख रहे हैं कि कहीं भी 0 से एंड नहीं हो रहा. सो इसका आंसर आप कैसा लिखेंगे मैं समझाता हूं, ध्यान से देखिए. फर्स्ट स्टेप लिखना है, for the number 6 power n to end with 0, it should be divisible by both 2 and 5. I already told you that any number which is ending with 0 should be divisible by 2 as well as it should be divisible by 5. Got it? That is 2 and 5 must present in its prime factorization. Two and 5 must present in its prime factorization. Let us see the prime factorization of 6 power n. 6 power n, the factors of 6 are 2 and 3. Okay. So in the prime factorization, we can find 2, but there is no 5. Two is present in the prime factorization of in the prime factorization of 6 power n, but 5 is not present. So 2 is present, but 5 is not present. I already told that in the prime factorization, 2 and 5 must present. Okay. So what is the conclusion? Can you tell? What should be the conclusion?
6 power n cannot end with the digit 0.
Yes. 2 is present in the prime factorization of 6 power n, but 5 is missing in the prime factorization. You can even write 5 is missing in the prime factorization of 6 power n. So 6 power n can never end with digit 0 for any n belongs to natural number. You put any natural number in the place of this small n. 6 power n is not going to end with 0. So this is a theoretical type of question, and these are the necessary things you need to mention in your answer. So 8 power n is asking us to check whether it will end with 0. End with 0 means in unit place, will it get 0 for any n value? N is a natural number. So n can take values 1, n can even take values 2, any natural number. If you are putting n is equal to natural number, will you get in the units place 0 or not? He is asking us to check. Let us just see what is 8 power 1 is 8, 8 square is 64, 8 cube is 512. So I am not getting 0 in the units place. It is not ending with 0, and let's see what is the reason and explain. Let us explain with step by step why we are not getting 0 at the end. Let's see. First step would be for the number 8 power n to end with 0, it should be divisible by both 2 and 5. That is if it is divisible by 2 and 5, then in its prime factorization 2 and 5 will present. Okay, so that is 2 and 5 must present in the prime factorization of 8 power n. Let us find the factors of 8 power n. What are the factors of 8 power n? 2 into 2 into 2 whole power n. 2 is present but 5 is missing. 5 is not present in the factorization. So what is the conclusion? What is the conclusion? 8 power n can never end with
digit 0.
digit 0 for any n belongs to natural number. You put any natural number, it is not going to end with digit 0. Why? Because it is not having 5. What's ध्यान से देखिए, focus. First of all, this is a separate problem and this is again a separate problem. So we have two questions in this. You can't combine these two. ये दो एक नहीं होते, अलग अलग है. So first of all, यहाँ पर ये दो numbers, these two numbers are composite. He is asking us to show that they are composite. Explain why they are composite. ये composite क्यों समझते हैं आप? Explain करो बोल रहा, ध्यान से देखिए. First of all, आपको ये प्रॉब्लम करना है तो आपको फंडामेंटल थ्योरम ऑफ अरिथमेटिक लर्न करना है. Which theorem? Fundamental theorem of arithmetic. This theorem says that any composite number can be expressed as product of primes. The statement of this particular theorem is any composite number can be expressed as product of primes. Let me write the theorem statement. Every composite number can be expressed as a product of primes. And this factorization is unique. So what is the meaning of this statement? To understand the meaning of this statement, firstly, you should know what is composite number and what is prime number. So when you write the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like this, if you write the natural numbers, some numbers having 2 factors, some numbers are having more than 2 factors. 5 is having only 2 factors, 6 is having more than 2 factors, 7 is having only 2 factors, 8 is having more than 2 factors, 9 is having more than 2 factors, 10 is also having more than 2 factors, 11 is having only 2 factors, 1 and 11, 12 is having 1, 2, 3, 4, 6, 12 more factors. So the numbers which are having more than 2 factors are called composite numbers. All these numbers are having more than 2 factors and such numbers are called composite numbers. And the remaining numbers which are having only 2 factors, such numbers are called what? Prime numbers. One is neither prime nor composite. Why? Because 1 has only one factor. If it is having two factors, prime. More than 2, composite. If it is having one factor, it is neither prime nor composite. Is that okay?
Yes,
Yes.
ma'am.
So we can say that 1 is neither prime nor composite, 2, 3, 5, 7, 11, 13, 17, 19, 23. All these are prime numbers. Here 4 is missing, 4, 6, 8, 9, 10. In between we have 8, 9, 10. This is 12. Here you have 14, 15, 16. So remaining numbers are composite numbers. Got it? So now you came to know about prime numbers and composite numbers. Now here the statement says that every composite number can be expressed as product of primes. Let's see. Can any one of you tell me one prime number? Sorry, composite number.
12.
So 12 is a composite number when I factorize 2 6 are, 2 3s are, 3 1s are, 2 square into 3. Product of primes is composite number. हर composite number product of primes expressed as product of primes. ये फैक्टराइजेशन यूनिक है. 2 स्क्वायर इंटू 3 का फैक्टराइजेशन सिर्फ 12 का है. कोई और नंबर को ये फैक्टराइजेशन नहीं आता. कोई और नंबर को ये फैक्टराइजेशन नहीं आता. इस वास्ते फैक्टराइजेशन यूनिक है. ऑर्डर चेंज हो सकता. कोई स्टूडेंट 3 से करा तो उसका ऑर्डर 3 इंटू 2 स्क्वायर आता. ऑर्डर चेंज हो सकता मगर फैक्टराइजेशन यूनिक है. ये कॉम्बिनेशन 2 स्क्वायर इंटू 3 सिर्फ और सिर्फ 12 का है. ये है थ्योरम, फंडामेंटल थ्योरम ऑफ अर्थमेटिक. हर कंपोजिट नंबर को आप प्रोडक्ट ऑफ प्राइम्स में एक्सप्रेस कर सकते हैं. यहां पर लिखा हुआ है एक्सप्रेस्ड एज प्रोडक्ट ऑफ प्राइम्स. फैक्टराइजेशन इज यूनिक. आपको जो फैक्टर्स आ रहे वो यूनिक है. कैन एनीवन टेल मी वन मोर कंपोजिट नंबर?
24.
Very good example. You have given me good example 24. Let me factorize 2 12s are, 2 6s are, 2 3s are, 3 1s are. 24 is a composite number. Why? Because we can able to express 24 as product of primes. अगर कोई नंबर को प्रोडक्ट ऑफ प्राइम्स में आप एक्सप्रेस कर सके तो वो नंबर क्या है? कंपोजिट नंबर होना चाहिए. और ये फैक्टराइजेशन यूनिक है. कोई और नंबर को ये फैक्टर्स नहीं आएंगे. इसका मतलब कोई और नंबर को 2 क्यूब इंटू 3 स्क्वायर आ सकता, 2 क्यूब इंटू 3 क्यूब आ सकता, मगर 2 क्यूब इंटू 3 पावर 1 सिर्फ और सिर्फ 24 को ही आ सकता. फैक्टराइजेशन यूनिक है. अगर आप कंपोजिट नंबर्स का कंपोजिट नंबर होता अगर आप प्रोडक्ट ऑफ प्राइम्स में एक्सप्रेस कर सके. तो ये है फंडामेंटल थ्योरम ऑफ अर्थमेटिक. I hope you have copied the theorem. Now I am going to the question. Here a number is given. What is the first number? I already told that these two are different questions. You can't club these two numbers. Separately you have to do Roman number 1. What is the number given? 7, 11, 13 plus 13. So this is one term. This is another term. Both the terms are separated by plus. We are having two terms which are separated by plus. In these two terms, I can take common. What common can I take?
13.
Common sense. 13 can be taken as common. Once I take 13 as common, 7 and 11 remain here and 1 will remain in the place of 13.
Sir, into 1.
Yes, plus in the place of 13, as 13 is taken common, plus 1 will remain. Got it? Into 1 you can write, of course, you can write 1 in the place of 13. Inside the bracket, if I try to multiply 7 11s, I will get
77.
77 plus 1 is nothing but 78. Now in the rough column, I would like to take the factors of 78 to how many times? 39s are 3, 12s are 3, how many times? 13s are na?
Yes, sir.
13 ones are. So now 78 is written as 2 into 3 into 13. This 78 is written as 2 into 3 into 13. How many 13s? There are 13, 2 13s. 13 into 13 is 13 square. 2 into 3 into 13 square. So we could able to express this given number as product of primes. गिवन नंबर को आप प्रोडक्ट ऑफ प्राइम्स में एक्सप्रेस कर सक रहे हैं, तो ये गिवन नंबर क्या होना चाहिए? कॉम्पोजिट नंबर होना चाहिए, क्योंकि हर कॉम्पोजिट नंबर प्रोडक्ट ऑफ प्राइम्स में एक्सप्रेस कर सकते. सो यहां कंक्लूजन क्या लिखना है आपको? सिंस 7 into 11 into 13 plus 13 can be expressed as product of primes. It is a composite number. Explain why. क्यों ये composite number है? ये composite number इस वास्ते है, वो नंबर प्रोडक्ट ऑफ प्राइम्स में एक्सप्रेस कर सक रहे हैं. वो नंबर को आप प्राइम्स में, प्रोडक्ट ऑफ प्राइम्स में एक्सप्रेस कर सक रहे हैं, इस वास्ते वो composite number है. Got it?
Yes.
Now this is the given number. Let us take 5 as common from this number. When I take 5 as common, 7, 6, 4, 3, 2, 1 and 1 will remain. What is the product of these numbers? Can anyone tell?
1008.
So 5 into 1009. 1009 is a prime number. Please remember that it is a prime number. So the given number can be expressed as product of primes. So fundamental theorem of arithmetic says that if a number is expressed as product of primes, then it is every composite number can be expressed as product of primes. So here in this case, as the number is expressed as product of primes, the given number must be composite number. Write down, since 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5, this is the given number, can be expressed as product of primes, it is a composite number. That's it. Any one of you read the question loudly?
There is a circular path around a sport field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point?
Okay, now see, I will be writing the steps. First step, if you read the question, Sonia is taking time taken by Sonia to drive one round, 18 minutes. Okay, write on. Time taken by Sonia to drive one round is equal to how many minutes?
18 minutes.
18 minutes. At the same time, Ravi is taking 12 minutes. Okay. He's asking when will they meet again? They both are starting at same point, moving in same direction, starting at same time. So when will they meet again at the starting point? So we need to find LCM of 18 and 12. LCM will give you the answer. Factorize 18. 2 nines are, 3 threes are, 3 ones are. Factorize 12. 2 6 are, 2 threes are, 3 ones are. 18 is 2 into 3 square. 12 is 2 square into 3. LCM. In LCM, if the factors are common, you will be taking bigger or smaller?
Bigger.
Bigger. Which is bigger among twos?
2 square. 2 square.
Bigger among threes?
3
So LCM is
3
4 nines are
36.
36. They both will meet together at the starting point after 36 minutes. Read on. Conclusion. Both Sonia and Ravi will meet at the starting point after 36 minutes. So LCM will give you the answer. I will explain why 36 is the correct answer. I will explain. Now see here. Sonia is taking 18 minutes for one round. For one round, she is taking 18 minutes. To make two rounds, she will take 36 minutes. Ravi is taking 12 minutes for one round. For two rounds, he will take 24 minutes. For three rounds, he will take
36.
36 minutes. So सोनिया, ये स्टार्टिंग पॉइंट है, 18 मिनट्स के बाद स्टार्टिंग पॉइंट के आके रुक रहे हैं, फिर और एक 18 मिनट्स के बाद फिर स्टार्टिंग पॉइंट पे आए, बोले तो 36 मिनट्स के बाद स्टार्टिंग पॉइंट में आए, उन्होंने 2 राउंड्स ट्रैवल करे। रवि 12 मिनट्स में 1 राउंड कंप्लीट करके स्टार्टिंग पॉइंट पे आ गए, फिर 24 मिनट्स में 2 राउंड्स कंप्लीट करके स्टार्टिंग पॉइंट पे आए, 36 मिनट्स में 3 राउंड्स कंप्लीट करके स्टार्टिंग पॉइंट पे आए। सो 36 मिनट्स के बाद वो दोनों भी स्टार्टिंग पॉइंट पे है, दोनों भी कहां पर है, स्टार्टिंग पॉइंट पे है। तो यहां पर सोनिया 1 राउंड और 2 राउंड्स ट्रैवल करके स्टार्टिंग पॉइंट पे आ चुके हैं। रवि 3 राउंड्स ट्रैवल करके स्टार्टिंग पॉइंट पे आ चुके, 36 मिनट्स के बाद दोनों भी अब स्टार्टिंग पॉइंट पे है। दिस क्वेश्चन इज, when do they meet again at the starting point? They will meet again at the starting point after 36 minutes. In 36 minutes, Sonia will be taking 2 rounds, Ravi will be taking 3 rounds, but their position is starting point. So for these type of problems, you would be taking LCM. Okay. I hope you understood this. Please note down.